welcome back students to one more series of your JEE as well as NEET chemistry. Right, as I've kept in the community tab, I think yesterday I've asked you how many, like as I said, I am ready with the tricks how for physical, organic as well as inorganic, and I also asked you how many tricks do you want per day. The response was huge. Thank you so much for that. Right, I promise I'll be uploading the tricks for you all so that you can directly apply these tricks during your examination. Right, so basically during your JEE as well as NEET, I think this year students, in one way, if I have to say, you're lucky enough of having time sitting at home and studying. Or yeah, certain exams got postponed. It's okay, but this year JEE as well as NEET as aspirants, you can comfortably sit relaxed and study for the examination. Right, so with this trick series, as I told you, I'll be doing the tricks which are involving organic chemistry, inorganic chemistry as well as physical chemistry. Right students, let's start off with the trick series. So let's go to the first trick. Right, so basically what is important? Time is the most important factor during your examination, isn't it? Right, so during this given time, so basically you need to solve your physics, you need to solve your chemistries, and you need to solve your maths also. For some, those have opted for biology. So that particular time, whatever is given, very less time, you need to finish off the question. So right, so for that I tried to really, it took a lot of time, almost more than a week time for me to collect, compile everything together. I tried to make different tricks. Let us go with the first trick, that is organic chemistry trick 1. Let me write trick 1. So right, what is that trick? Let's see. So basically, let us start with the first tagline, that is SNLTS. So what is the full form of this? You need to remember this trick. For what is it standing for? Let's see. S stands for very nice. I felt it's I thought smells. S stands for smells. N stands for natural. L stands for like. T stands for teen. S stands for spirit. This is the tagline which I have given for the first trick. Remember, what is SNLTS? Spells natural like teen spirit. Hope you are noting it. Ma'am, where can I use this SNLTS? Remember, let's see this. So SNLTS, when I said smells natural like teen spirit, the most important background behind this, let me write that. So hope students, you've noted it. Right, so how to study this and how to apply this in exam, very important thing. So S stands for the first, what is that? SNLTS. Once again, let us repeat. Smells natural like teen spirit. Right, now S stands for substrate. N stands for nucleophile. L stands for leaving group. T stands for temperature, as well as S stands for solvent. Right, let us write again. S stands for substrate. N stands for nucleophile. L stands for leaving group. T stands for temperature. S stands for solvent. So these are all the 1, 2, 3, 4, 5 important concepts or the topic which you should remember whenever you're solving organic chemistry mechanisms like the SN1, SN2, E1 in E2. Right, so let us start. So SN1, SN2, E1, E2, which one will help us? Now in SNLTS, I said first is a substrate. Always remember, when I take the concept of substrate, what should I remember? What are the different types of substrates we have? We have primary substrates, 1 degree substrates. We have 2 degree substrates. We have 3 degree substrates. Yes students? Yes. So whenever we are saying about 1 degree substrate, so basically what is 1 degree substrate, if I have to say? So here this 1 degree substrate, just like your methyl group. Always remember 1 degree substrates. What will they help us? They will help us, or they will always allow us to, means it will undergo SN2 as well as E2 mechanism. When I take the secondary substrate, they are going to, they will undergo SN2 plus SN1 plus E2 plus E1 mechanisms. But when I take the tertiary substrate, remember they are going to catalyze, means they are going to undergo only SN1 and E1 mechanisms. This is the most important trick you have to remember. So substrates, primary, secondary, tertiary, and these are the type of mechanisms they are going to undergo, right? Suppose if I have after substrates, if I am going to the next thing, what are they? Let us come back. The next type is nucleophiles, isn't it? Right. So basically nucleophiles, when I have to speak about them, what are nucleophiles, right? So they're electron rich or electron deficient. They're electron rich species, isn't it? Right. So here one important clue you have to remember. When it is a nucleophile, and we have two types, isn't it? Weak nucleophiles and strong nucleophiles, right? Always remember strong nucleophiles. What are the strong nucleophiles which we have? Let us list out. RO minus is a strong nucleophile. OH minus is a strong nucleophile. NH2 minus is a strong nucleophile. RLI is a strong nucleophile. What is the specialty of this? Whenever you have these strong nucleophiles in the reaction, they will always promote which type of reaction? SN2 mechanism reactions only. This is one important trick. Once again, whenever you find these strong nucleophiles, which type of reaction it promotes? It promotes SN2. Ma'am, why? What is the important thing? Because the leaving group, whatever is there, the leaving group, whatever it has to, is there in that particular reaction, it has to be, forced off. You have to take out the leaving group. Correct? Yes. So once again, substrate, primary, secondary, tertiary. Primary undergoes SN2 and E2. Secondary undergoes SN1, SN2, E2 and E1. Tertiary undergoes E1 and SN1. Suppose if it is a nucleophile, strong nucleophile like this, they are going to promote always SN2 reaction mechanism. That's over. S is over, N is over. Then I have to come back to the next concept, that is leaving group. Let us write that leaving group. Right. So now the third category is leaving group. Now in leaving group, again, what are the different types of leaving group you have? You have good leaving group, then you have mediocre leaving groups, then you have fast leaving groups. I mean, it's good or fast. Okay. Good leaving groups or great leaving groups. Next would be mediocre leaving groups or very lazy leaving groups, which will not leave that particular thing and go. So when I have to speak about the leaving groups, two things you have to remember. Great or great leaving groups is one I'm going to categorize. The next category is mediocre, means the middle type. Mediocre leaving group is one more. Always remember, great leaving group example is I minus. Mediocre leaving group is example is Cl minus. Okay, right. So when I have to speak now, the least, if I have to say, I can go with F minus. So in the great leaving group, which type of mechanism they always promote? They are going to promote E1 or SN1 mechanisms only. If I have the mediocre, suppose if I have Cl minus in the particular reaction given, in the question given, they will always promote E2 as well as SN2 mechanism. Remember this one more trick of what you should remember. So substrate I have given one trick. Nucleophile I have given one trick. Leaving group also I have given one trick. Now let us go to the next one, that is temperature. Right, students, hope you are noting it. So when I have to go to the temperature concept, right, so temperature is the next factor which you have to remember. Right, so again in temperature in the exam, remember in the question, if the temperature is given or if the temperature mentioned is more than 50 degrees centigrade, remember this. If this temperature is mentioned, if the reaction happens at more than 50 degrees centigrade, you have to immediately relate that elimination reaction is going to happen. Elimination is favored. So elimination reaction is favored. This is one more trick which you have to remember, favored. Right. Suppose if the temperature is less than 50 degrees, means lower than this, then always remember substitution reaction is going to be favored. So what is the clue you have to remember? In the question, if they give you more than 50 degrees, elimination reaction. If it is less than 50 degrees, substitution reaction is going to be favored. This is also over. Now, what did I complete? Substrate I have completed. Nucleophile I have completed. Leaving group I have completed. Temperature I have completed. Now, last but not the least, I have to talk about solvent. Right. Let us rub this and write the solvent, students. Yes. So, solvent. So, when I take the solvent, what are the types of solvents we have? We have protic solvents. is one category. Then we have one more category, that is polar aprotic solvents. Protic solvents and polar aprotic solvents. Correct? Yes. Now, what are the examples of protic solvents? Water, alcohols, HF, ammonia, or all polar, all protic solvents. What are polar aprotic solvents? Means polar aprotic solvents are those which will not have that, means, you know, acidic hydrogen ions. H plus ions they will not have. Once again, protic solvents examples are water, alcohol, hydrogen fluoride, ammonia. Polar aprotic solvents examples are DMF. What is DMF? It is nothing but dimethyl formamine. Correct? Right. So I'll write the examples once I rub this. Let's see what actually does it promote. So always remember, if you have protic solvents, like as I said, let us write the examples on this side. That is water. One is alcohol. One more is HF. One more is ammonia. What will they promote? Always they're going to promote SN1 or even mechanism. I have done a video on SN1 reaction, even reaction also. Please watch that. You will understand what actually is SN1 even. Suppose if I have polar protic solvents, what are the different examples? I said the examples are DMF. One more is HMPA. One more is DMSO. I'll tell you what this means. They are always going to promote the next one, that is SN2 as well as E2 mechanisms, right? Why this one will undergo only promote only SN1 even? Because they stabilize the cation intermediate. Correct? Yes, there is a formation, they'll stabilize the cation intermediate. But here in this case, in SN2, because they do not form any hydrogen bond. They don't have any hydrogen, isn't it? They do not form hydrogen bond and they cannot interfere as much as a nucleophile. So that's the reason they prefer SN2. So now I said, what are the full form of this? DMF stands for dimethyl formamine. HMPA stands for, H stands for hexamethyl phosphoamide. DMSO stands for dimethyl sulfoxide. Dimethyl sulfoxide. So remember these clues, students. So the first trick which I have told you is, always remember, smells natural like teen spirit. What is that? S stands for substrate, N stands for nucleophile, L stands for leaving group, T stands for temperature, S stands for solvent. All the 5 characters you have to remember. So again, let me meet you with the next trick of this series. Next trick, students. After SNLTS, what is that? S stands for substrate, N stands for, here students, nucleophile, T stands for temperature, L stands for the leaving group, and then the solvent. Right. Now let us come to the next trick, very important trick in the exam. Suppose if there is a question which has either free radical, suppose if it has a carbene reaction intermediate, suppose if it has a carbanion, suppose if it has a carbocation, right? If they ask you a question like this, which is either whether it is diamagnetic or paramagnetic, compulsory question it is. Let's see. So here in the trick, next important thing you have to remember, how to solve paramagnetic or diamagnetic question. Let me write the question. How to solve paramagnetic or diamagnetic nature of reaction intermediates. Suppose this is given to you, what are you supposed to do it? Reaction intermediates, right? So here basically remember the different types of reaction intermediates. What have we learned, right? In general organic chemistry, we have learned reaction intermediates, some different things. Like, let me take the first reaction intermediates. The first, let us divide the, okay, my line is not straight. I have to make one straight line. Okay, I'll try. Okay, now also it is not straight. No problem. This is not the important thing for me. Learning the concept is important. So the first reaction intermediate which I'm going to learn write is carbanion. Okay, so carbanion, if I have to say how many valence electrons does it have? So valence electron is where we are going to calculate whether it is diamagnetic or paramagnetic. So let us write magnetic behavior, right? So when I have to take the structure of carbanion, what are the different types of this one carbanions? We have primary, first is methyl carbanion, primary carbanion, secondary carbanion, and tertiary carbanion. Let us draw that and write the valence electrons. So when I have to take the carbanion, the first type is methyl carbanion. Carbanion means negative, isn't it? So there is one lone pair of electron here. Let me put this. So first is methyl carbanion. How many valence electrons does it have? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 7, 8, isn't it? So total number are 8. Valence electrons are 8. Right. Next important thing, when I have to take the primary carbanion, so which is with one methyl group. This is one CH3, one more CH3 ... This is primary. So the number of valence electrons 8 again. If I have to take, now this one is what? This is primary. Suppose if I have to make secondary carbanion, what will I do? I'm going to take out one hydrogen and introduce this. This becomes secondary. Then also it is 8. Suppose if I have to do tertiary carbanion, what will I do? I'll take out H and make CH3. Now also 8. That means in a carbanion, whether it is methyl, primary carbanion, secondary carbanion, or tertiary carbanion, the total valence electrons are 8, isn't it? 8. When it is 8, whether it is paramagnetic or diamagnetic, all are paired, isn't it? Half are filled, all 4 and 4, 8. So compulsory, because there is paired paid number of electrons or domains, we call it as diamagnetic. So carbanion is diamagnetic in nature. Clear, students? Right, done. Let us next write free radical. So in the second one, or the second category, when I take the second part of the trick, which is free radical, right? So what is the structure of free radical? If I have to draw, let me rub this properly. Free radical, RADICAL. So free radical structure, free radical looks like R, C, R and dot. Now count the number of electrons. 1, 2, 3, 4, 5, 6, 7. So the number of valence electrons is 7. Isn't it odd? Odd. That is the reason free radicals are always paramagnetic in nature. This is clear, students? Done. Yes. The next type of reaction intermediate which we have is carbene. So let me take out this and then write the next one. So the next category of reaction intermediate is, again let us make 3 lines, right? The first one is reaction intermediate, Ri. The next second one is valence electrons, second column. Third column is magnetic behavior, right? So the next reaction intermediate, what do we have? We have carbenes. So what are carbenes basically? Carbenes, the formula is R, C, R, dot. Now count the number of valence electrons. 1, 2, 3, 4, 5, 6. 6, isn't it? So if it is 6, isn't it odd or even? It is even. So I can comfortably write it is a diamagnetic. It is, when carbon is there, it is diamagnetic in nature. That's done. Suppose if I have the next reaction intermediate, that is your carbocation. So next reaction intermediate is carbocation. How are you writing carbocation? Basically, carbocation is denoted, it is plus, isn't it? So hydrogen, carbon, hydrogen, carbocation. Cation means plus. This is hydrogen. Now count the number of electrons. 1, 2, 3, 4, 5, 6. Total number of electrons are 6. Again it is paired. So it is diamagnetic in nature. So the next trick, remember, diamagnetic. Now let us erase everything and combine together. So in trick 2, I have set one important thing. What is that? Carbanion. Let me write a bit above. First thing, carbanion. Carbanion. Number of valence electrons are 8. So it is diamagnetic in nature. Diamagnetic in nature. Second category, I said it is free radical. Free radical. How many are the number of valence electrons? Number of valence electrons, as I've shown you, 7. So it is paramagnetic in nature. Next category of reaction intermediate, which I said is carbene. How many valence electrons are there in carbene? Carbene has 6 valence electrons, so it is even, so it is diamagnetic in nature. Next, our fourth one is carbocation. Carbocation. So in carbocation, how many valence electrons do we have? As we have seen, 6. So it is again diamagnetic in nature. So remember students, whenever you have these reaction intermediates in the question, if they ask what is the magnetic behavior, this is what you have to remember. So diamagnetic means paired, paramagnetic means unpaired number of electrons. So this is what is your second trick. I think it helps you to add on or helps you to solve the question given. Let us come back and do the third trick.